I request our session chairman, Sri G.S. Prasad sir, ex-CEO, RSP Cell, along with our reporter, Sri P.K. Sarkar sir, CGM in charge services and director, NSPCL, to join on the dais, sir. Sir, if we have the permission, we can start the presentations. To start the first session, and the total time which is given to our presenters is the 7 minutes. The first bell ring on 5 minutes and 2 minutes to complete your session. Okay. Recently our TIC sir, Mr. Nivan Das Gupta sir, and along with our ED Works Mr. HD Kumar and our distinguished guest Mr. M.K. Verma, Vice Chancellor of SAIL-Bhilai, just joined the gathering. So we welcome you, sir, and with your permission, we are starting the session. And now for the first presentation, I invite Mr. Ashok Kumar Vishwakarma giving the presentation on firm step towards sustainable color-coated products. And time I have already told them. There will be total 7 minutes, sir. The first bill will be done on 5 minutes, and after that we will give 2 minutes to complete your.
Thank you. Good afternoon, everybody. Senior dignitaries and delegates from different industries. Much has been told by APL Apollo CEO yesterday about infrastructure development, green building concepts. So, I will touch 2-3 points where so far we have covered this sustainable technology, sustainable processes and equipment, but here we are giving the customized finished product where we can put our equipment and where we can use the sustainable processes or decarbonization processes. So, firm steps towards sustainable color-coated products. So, already it has been covered our CEO yesterday. So this is the gist of our APPL Raipur plants. We have 4 plants. We have 600 acres of land where we are producing both tubular as well as flat products. Out of that 4, we have 2 flat products complex and 2 tubular where we are producing 8 mm into 8 mm to 500 into 500. And very soon we are going to produce 1000 into 1000 into 40 mm. That will be the first in India and the second in the world. So approximately 85,000 tons per month is the capacity, and overall 1 million tons. Very soon we are going to touch 1.5 million tons in a single unit. This is the gist of 2 types of products, hollow section tubular and the flat products. We have different types like powder full hard, CR black anneal, CRCA rod close anneal, aluzinc coils, that is popularly known as galvanized, pre-painted aluzinc and pre-painted galvanized. In the tubular section we are producing precision commercial tubes, that is from hot roll, cold roll, CRCA, GI, etc. And then black HR hollow sections and blanks. Almost 90% of our own plant structure is made by us. So the corrosion problem, every year almost 5% of the world's GDP is lost on account of corrosion, and in India approximately 4% of Indian GDP is lost on account of corrosion. That is coming around $100 billion, which is nearly about 8.21 lakh crores per annum. So imagine what we are losing. So for that we have to think about sustainable infrastructure where we can put our equipments or technologies or processes. Like here comes the one of the very versatile element, that is zinc. So zinc says to the iron, don't worry, I am here, I will protect you. So zinc acts as a sacrificial anode and it protects the steel, and even though there is any scratches, it protects the surrounding steels. On the right side you can see that this is cathodic protection in the galvanic series. Zinc is above steel, so zinc acts as a anode. So whatever the corrosion taking place, it is happening on the zinc and it is protecting the cathode, which is steel. But whatever the life is there, it is continuously going depleted by sacrificing its own life and protecting steels. Here it is the study done by ISO team over a period of 60 to 70 years over that corrosion loss, and they have published this ISO 9223 and ISO 12944 series of standards. So on the left side we can see that from C1 to C5 it increases the corrosivity level of atmosphere. C1 is basically very ideal situations. Nowadays it is not found anywhere. So starting from C2 onwards, the corrosivity level is increasing. That colored columns, that low carbon steel, if it is not protected, so what will be the mass loss per year and the thickness loss per year? On the yellow colors, zinc mass loss per unit surface area per year, and so in the subsequent slide we can see that how it is protecting the steel. So here the comparison is between the unprotected steel structure with the galvanized steel. So here by this we can see that C5 is almost 84 times more corrosive with respect to C1 atmosphere. C4 is almost 22 times, C3 is almost 22 times. So this green, that is very low. So expected life is from 100 years to 400 years. But when we are changing the atmospheres, the life is going down up to 1.3 years to hardly 4.5 years. The same product. By using this, as per the previous slides table, zinc reduces corrosion loss by 20 times and thus it protects the steel below it. Similarly, this base metal thickness loss, which is GSM, so up to 500 GSM losses per year, it reduced to 60 GSM only when we are using galvanized. Now we are using color coated. So I will explain that it is not the only normal color coated products. Here we can see that in the center of the steel base is there, over and below there are zinc layers. Then there are chemical treatments. It's very important because it makes the platform where the paint will bond with the zinc surface. So top surface and bottom surface, generally roofing sheet uses 25 micron, and the bottom coat it is around 12 to 13 microns. As we have seen yesterday, we have developed one color coated Perleo, that is named as Perleo, both sides 25 microns. So 20 to 25 microns based on the customer requirement we have developed. So paint is saying to zinc, सबसे पहले मैं सेक्रीफाइस करूंगा, देन आपको सामने आना है. So it acts as a barrier protection to the zinc layer. Till it is intact, there will be no cathodic reactions on the zinc layer. So we can enhance the light. Here we will not go into this primary, secondary, tertiary, how the in number of color sets can be produced. So far we have produced more than 80 color sets. This is color space. We will escape. So in the C purlin, because there are both sides 20 microns and it is not the vertically, horizontally, it is vertically, so both sides are equally coated. So till it is intact, so it will protect the substrate. So far we have developed 6 color sets as per the requirement of the customer in the market. We can supply more sets also. These are the tests carried by. Why we are different from other suppliers. As per specifications, they are giving 500 hours of this weathering test, humidity test, or say salt spray test. We are achieving more than 1000 hours. So 100 hours is almost equivalent to 2.5 years. So 1000 hours it is.
1 minute. Please finish it up.
So this is the differences between our product and the other suppliers' product, by which we claim we have 2-3 types of warranty products, where we are claiming more than 15 years warranty, 10 years warranty, depending on the type of the beds we are using. This is the comparison between color coated purlin and the galvanized purlins. So how color coated purlin is better than the normal galvanized purlin. So far it is a new product for us, and we have supplied 2 of the renowned OEM customers. We are like in application will be at Hindustan Aeronautics Limited, Bengaluru also. So we have just started, and in the coming days we are going to add many more features in our products. Thank you.
So the first paper from AVL building material. It's a nice solution. I will, thank you very much. I request coming up presentation, all the presenters to be specific within time limit. As the time is already passed, I will take only one question from the viewers. Anybody, if any questions, please ask. Any questions, please? Okay. If there is no question, you can proceed on. There is one.
Sir, I'm Deepak from SAIL-Bhilai. Are you also using galvanum for structural steel?
Yes, we have both types of product, galvanum as well as we have 2 galvanizing lines. One is dedicated for galvanizing and the second is for galvanum. So both we are pre-painted galvanum and pre-painted galvanized.
Okay then, thank you very much. I will invite second paper presentation. The paper topic of the paper is Decarbonisation Sail, the Way Forward. Mr. Sandeep Sahu, Nitin Agarwal, both are from SMS to DGMs. I will again request, please be specific. Okay.
Good morning, ladies and gentlemen. Respected DIC sir, Bhilai Steel Plant, ED works sir, dignitaries off and on the dais. Ladies and gentlemen, I start my presentation by quoting Rabbi Abraham J. Tversky, who had said, "Angels do their job and move on silently without leaving a mark. But we humans do it in a very devastating way. It is so that the emission bucket will be filled in another 7 to 8 years to put Earth into an irreversible climate change." I welcome all of you to my presentation on the paper Decarbonizing Sail, the Way Forward. It would be a summary of all the previous presentations that my friends from Steel Authority of India Limited have been telling you since morning. So what is decarbonization? Decarbonization basically targets climate stability, targeting a healthy environment for all of us, economic stability, directed towards achieving sustenance. So steel, as we know, is one of the most important material of modern life, making it is highly carbon intensive. And 1 ton of steel actually produces 1.8 ton of carbon dioxide emissions globally. So, but why do decarbonize steel? Steel contributes to around 8% of global and 11% of India's emissions are from steel. And steel production is set to rise by 7-fold. So, with India's economic growth, the emissions also tend to increase. The mega trends indicate that 14% of steel companies' potential values at risk. And so are the growing investor and public interest towards sustainability and greener products. Imperatives for India are basically drawn from Mission Panchamrit, Government of India, to reach net zero by the middle of 21st century. As you look at the two popular routes of steel making in India, the average from BF-BOF, the most popular one, is 2.5, and from the coal-based DRI and electric arc furnace is around 2.8. Well, the thermodynamic limit of BF-BOF process is around 1.8. But if you look at this DRI-based electric arc furnace with green electricity and green hydrogen, it can be touched to as low as 0.1 ton of CO2 per ton of crude steel. For the way forward, there are basically two ways in which how we can do it: by controlling input, like raw materials and electricity, and the other way is controlling output, that is by increasing or improving our efficiencies, circularity, and carbon capture and utilization. Well, there are many significant barriers in the net zero dynamics. First and foremost is that the decarbonization solely through science-based projects is not really possible. Many of the furnaces in India and China are quite new. DRI electric arc furnace with green hydrogen is yet to be economically produced. So if you look at the carbon intensity, we have been significantly coming down all through these years, and we are hovering at around 2.5 right now. But how to decarbonize? If you look at this, what we did for Steel Authority of India Limited, the most significant opportunity that lies in front of us is that slowly and steadily there are markets for carbon neutral products coming up, and there is significant amount of government support in achieving our targets. So decarbonizing SAIL is basically through three phases. First and foremost, we target to control carbon-based reduction process, basically through efficiency increase. The next would be to change over to carbon-free technologies. Many said hydrogen, or there might be some other alternative, we don't know, in the future. Then there would be a tumultuous phase called the transition phase. Mission for way forward in Steel Authority of India Limited basically can be divided into three phases. In the first phase, we are targeting minimizing CO2 emissions by increasing process efficiency, MODEX, with best available technologies. In the phase 2, we target optimizing carbon neutral technologies with the existing one. And in the last phase, we are targeting to attain net zero with whatever contemporary technologies that would be available at that time. CCUS, maybe RE, maybe alternative fuel reductant, hydrogen, again as a question mark. We are not just focusing on just one aspect of our business, but every aspect, starting from leadership, strategy, partnerships, processes, people, change intervention, results in metrics, resources, and this all through with the help of many vendors, collaborators, academia, and everyone. We have a 1 lakh crore capex plan by 2030, which we are not just targeting larger blast furnaces, but also more efficient blast furnaces. We are striving to generate a partnership ecosystem within SAIL, and with help of all our vendors, our suppliers, technology partners, government, Ministry of Steel, agencies interested in the field, NTPC, NSPCL, Educational and R&D Institutes, National Hydrogen Mission, Steel Research Institutes, etc. The low-hanging fruits that we have started to target is, we have to get energized ourselves by adopting renewable energy more and more. Increased share of renewable energy is first the priority. Efficiency and productivity enhancement across our plants and processes, improved maintenance practices, heat recovery and energy efficiencies. And all these prioritized process challenges are directed towards the most significant contributors to the process: blast furnaces, sintering plants, coke ovens, and basic oxygen furnace. When you look at the raw materials levers, we are targeted to increase the Fe content of sinter by increasing the Fe content of lump ore, increasing the use of pellets to the level of 25 to 47%. for the pelletization capacity addition, we are targeting around 19.2 million ton of captive pelletization capacity in SAIL. Blast furnace key levers include hot stove, heat recovery, TRT pellets, PCI, and all steps are being taken in each and every steel plant of Steel Authority of India Limited. We are enriching injectants with the help of oxygen. We are signing memorandum of understanding with significant decarbonization partners. We are going to attempt hydrogen injection at SAIL-Bhilai Steel Plant with one of the partners. Well, our CDI target is to achieve 170. Recently, just 4 days back, SAIL-Bhilai Steel Plant has attempted injecting biochar in their blast furnace, which is a very welcome step and first time in Steel Authority of India Limited. Blast furnace also target increasing the amount of injectants from like coke oven gas, fuels from pyrolysis of tires, natural gas, which have a very significant CO2 reduction potential. The future technology of top gas injection with CCUS has a potential to reduce around 65% of the total savings. Similarly, there are levers for coke oven. In the morning we saw how we are targeting to reduce coke moisture in few of the steel plants of SAIL, and so is the Sinter plant. With the blast furnace strategies, our blast furnaces, the smaller ones are older one, so it's a very right opportunity for us to change over. Retrofitting is not possible because of many space constraints. And in contrast, we are targeting process material and energy efficiency. Waste gas capture is to be increased. New converters have already been planned with increased amount of automation. We are trying to convert sludge to micro pellets. Recently we converted around 100 ton of GCP sludge into briquettes, and it was tested in our converters. It is a good potential saving. The challenge of BF slag is very significant. We have collaborated with ICAR to produce 13 new slag varieties which are under development. It is for basically for soil conditioning and conditioning with cow dung and acidic soils. We are targeting mills also. Recently, in terms of process efficiency, we could produce 555 numbers of feet from a single caster number 5 at Bhilai Steel Plant. 36 conditions were flown in, and this is a national record in terms of new caster in tundish, increasing tundish life. I will take 1 more minute, sir. Initially I was told that there will be 10 minutes to speak, so I will take 1 more minute, please. Sir, please. And in Bhilai Steel Plant, cast number 6, we could achieve 66 number of hits from a single tundish. So from this 66 hits, 7,500 tons of hits could be directly charged to plate mill for the first time ever in Bhilai Steel Plant. We are embracing automation IT with, yesterday we saw some presentation on deep learning, video analytics, vibration monitoring, digital twins and modeling software. In renewable energy also we have to target, we are targeting around 43%, that is 384 megawatt by 2030 as per RPO. We are also planning to come up with combined cycle gas turbine, harnessing solar power, few suggestions like canals to be utilized for solar power plants, power turbines, etc. Floating solar power plants are coming up all across SAIL with the help of NSPCL. We are taking care of environment. Till date, SAIL Steel Authority Limited has planted 22 million trees till date. We have converted a road completely with the help of waste plastic. We have taken care of our closed down mines at Purnapani. 250 acres of land were completely converted into a green patch. Local residents could earn livelihood from that plant. Restoration of Megatabur and Kiribur. In carbon capture, we have partnered with IIT Bombay and Ramcharan Group. The journey from 30 to 70 would be actually a combination of all the technologies that you are seeing here. Hydrogen and nitrogen, natural gas based injection, converting them to green chemicals, CCUS, DRI electric arc furnace, which we are set to explore, renewable energy joint ventures, scrap sourcing, and finally taking help of the Great Eastern Pipeline project that is coming up in the country. So the roadmap for SAIL is to first and foremost get everyone on board, spread intensive awareness. Strong collaborations would be coming next. Circular economy, increasing efficiencies, best available technologies by 2030 so that we reach the target of around 2.19 ton of CO2 by 2030. And then SAIL mission towards 50, we have to start our efforts toward alternate reduction research, joint venture, hydrogen, fine space processes, CCUS commissioning, and finally with all these efforts, we are very optimistic that we will be able to achieve the net zero steel maker that we aim to become one day. Thank you for your patience.
Thank you, Sandeep Saur. It's a nice presentation and it's a relevant topic. Now invite queries from, at least 2 queries, there is a time. Invite queries from our viewers, please. Anybody? It's a very relevant topic. There has to be some queries. Okay, please.
Just one query.
Okay.
Thank you. Very nice presentation. Thank you so much for enlightening us and thank you so much for enlightening and taking us have a view on the strategy by the SAIL. So just one question. I think in the earlier session there was a question and it is linked here. When we are calculating this carbon emission, actually CO2 emission, so right now it is totally based on scope 1 and whatever numbers is being shared here is based on scope 1, which is not the true picture of when we are talking about CO2. So I have just one question in this strategy, whether you are targeting these things with respect to only scope 1, then I think it's, or you are taking into account the scope 3 calculation.
At present, SAIL actually focuses on scope 1 and scope 2 only. In the later stages, we have planned to come up with scope 3 calculations also.
So these your targets will
Keep-
remain valid with this.
When we are targeting, obviously we are targeting the best. We have to include scope 3. Without that, the actual figures won't be right. That is how the entire industry is planning to target.
Sir,
I request
CO2
permission.
emissions in SAIL are calculated considering scope 1 and scope 2 both, not only scope 1.
Ma'am, thank you, but that is the point. When we are talking about up to 70 net zero, it cannot be only based on scope 1 and scope 2.
No,
So that's my submission. Thank you very much.
Very good question. Really, it's a pertinent question. Anybody?
We have considered all three, scope 1, scope 2, scope 3, when we are talking about 2.216 and 2930, that is considering all three. My question in the previous session was, WSA has given certain intermediate products. Okay, if you are using certain products which are not considered by WSA, okay, whether you have considered footprint of that particular product. That was my question.
So my understanding is, as of now, there is no standard, across industry, there is no standard method of calculation which can be shared, because we are also exploring and partnering with that. So looking forward, because we are talking about the collaboration, that is the right point. If we can determine scope 3 calculation, because that only one single plant cannot do that. All have to come along.
I think this is the established procedure. World Steel Association procedure is established. More than 200 industries are following it, and every year we are calculating it and we are uploading it.
Sorry for interrupting. Let us keep this discussion for later on. I have a question regarding conditioning of soil. You just mentioned, sir. What efforts are being made?
Sir, ICAR is our partner and 30 new slag projects. It is Indian Council for Agriculture Research. So with them we are developing, we have already developed 13 new slag products. 13 number of slag products. So that will be used for conditioning, because there is a problem of leaching in the slag. Directly they cannot be used, so they have to condition. Sir?
When did you take this present?
Sir, I think these projects are in continuation right now.
Okay.
Okay, thank you very much, Sandeep Rahul. Now coming to the paper third of this session, that is introduction of residual stress in rail, probable causes and reduction techniques. I invite R.P. Singh on this stage.
Good afternoon, all of you. My topic is introduction of residual stress in rail, probable causes and its reduction technique. We know that rail is energy efficient and low carbon by design due to the low addition between train and track when compared to the other motorized mode of transport. And rail guides the train wheel and transport the load to the train to the ground. Residual stress can lead to rail failures, impacting the loading range, track safety and overall reliability. And what is residual stress? Residual stress are a system of stress that can exist in a body when it is free from external forces. Residual stress are elastic stresses. The maximum value that can reach is the yield strength of the material. Residual stress in rolled product is generated whenever they undergo non-uniform plastic deformation, and it occurs due to inhomogeneous change in volume and shape. Residual stress in rail. We know that life of rail depends on the rate of wear under the action of wheels and formation of rate of propagation of fatigue cracks. And tensile residual stress are harmful because they help in crack development, and compressive residual stress make positive effect on fatigue like fracture stress and stress corrosion. And as per Indian Railway specification, this limit is 250 megapascal. Fracture of rails. Rail deform plastically when total applied stress is more than yield stress. And what is total applied stress? Total applied stress is equal to bending stress due to wheel load plus thermal stress due to temperature differential and residual stress in rail. Bending stress and thermal stresses are generated during the service of rail, and residual stress is generated during the rail manufacturing. Rail fractures by other forces also that can defect a critical size. And what is the critical size of defect is Q into K1C multiplied 2 by pi into sigma square, where sigma is the total applied stress and K1C is the fracture toughness of material and Q is the safe factor. You can see in the equation, as the applied stresses increases, the critical defect size increases. Causes of residual stress in rail. Residual stress in rail are produced during the service and manufacturing process as well. And manufacturing process of rail consists of processing through three processes, that is hot rolling, cooling and straightening. And it has been seen that highest residual stress in rail are generated during the straightening process. Why straightening is required? You know that rail are restarted after hot rolling and subsequent cooling on the cooling bed. Straightness of rail is one of the important factors for the quality and commercial value. And rail straightness is very important to safety and comfort in rail travel. Bending of rail will create problem in joining two rails. Straightening process will redistribute the residual stress during cooling process. What is straightening fundamentals? During straightening process, rail is driven through series of holes located alternatively below and above it. During the rail movement, rail is bent up and down. This is the top view of rail rolling straightening machine. There are two types of rollers arrangement are there. One is horizontal rollers and others are vertical rollers. Profile of residual stress. Usually longitudinal residual stress after straightening is C-shaped, and head and foot are subjected to longitudinal tensile residual stress, while wave is subjected to compressive residual stress. This type of profile is unfavorable due to the service condition. Working stresses and residual stress can cause fatigue crack and fatigue. Why concern about high residual stress at foot center? Here you can see in the photographs there are two types of residual stress profile. One is used rail and other is for new rail. And you can see that effect of residual stress is smaller in rail head than the rail foot. Working stresses in rail head are compression stresses, while working stresses in rail foot are tensile. So it has to be added in the tensile residual stress, and that lead to failure of the rail. Measurement of residual stress in rail. For measurement of residual stress, you are uses strain gauge. It is used for measure of strain, and the resistance of strain gauge changes when the force is applied, and this change will give a different electrical output. Strain indicator and recorder. Change in resistance due to strain induced in the strain gauge is measured and converted to the micro strain value by using strain indicator. And as per Indian Railway specification, we are using transverse template cutting method. This is the destructive method which we are using. In this method, 1 meter sample is cut from the rail, leaving from 3 meter of the rail section, and the surface of sample is carefully rubbed with a fine grinding stone and emery paper. The cleaned and marked test location is prepared and strain gauge is installed. This strain gauge is fixed by using M-bond 200 adhesive. After adhesive cures, connecting wires and solder the strain gauge terminals. And after that, 20 millimeter slice is cut from the sample to ensure the strain is, and after ensure that gauge is positioned at the center. After slice is cut, the relaxed strain is again measured by using the strain indicator, and that indicator provides the strain in the micro strain. And by using the formula stress is equal to Young's modulus into strain, we can calculate the residual stress in rail. And Young's modulus of the rail steel is fixed, that is 2.01 into 10 to the power 5 megapascal. Residual strain at foot center before and after straightening. Here we have taken two grades of rail. One is 880 and other is 260 grade of rail. And here you have seen that average residual stress before straightening for both grade is 81 and 66 MPa respectively. And after straightening, that residual stress is 179 and 184 MPa respectively. So we can see the average residual stress in R260 grade rail before straightening is lower than 880 grade and higher after straightening. And foot center always contains tensile residual stress before and after straightening. So experimentally we have seen that 2/3 of residual stress are generated during the straightening process. Causes of residual stress, there are various causes: inconsistency in temperature along the length and cross section of loom, high range of misrolling temperature, high camber in rails due to non-uniform cooling at cooling bed, less number of rolls in straightening machine. Measures taken for reduction of residual stress: to reduce thermal residual stress, rail shall be cooled at slow cooling rate. Camber in rail has direct impact on residual stress. To lower the camber, rail must be stacked proper and proper pre-cambering is required. And also high number of rolls in stacking machines results in lower value of residual stress. Study the displacement and reaction of rollers at different loading processes. Controlled cooling to be adopted for different portion of rail, and also heat treatment of rails to be given after straightening. Thank you.
Thank you very much. Very important product and it touches our life, everybody's life. Any queries? Yours please. So, we'll switch over to the next paper. If there is no query, we will switch over to the next paper. Thank you. Thank you.
Thank you.
Next paper is from Tata Steel. Design and development of Y700 HSL steel for L&D and structural application. Presently, Subhankar Das, please.
Hi, very good afternoon to the esteemed chair, esteemed speakers on the dais and dignitaries and the delegates over here. I'm presenting this particular case on developing Y700. So you may wonder that how come this sort of topic features for the decarbonization program. So just to give you a sorry for the glitch.
Technical team, I request.
You need to go one slide before. Yeah. So this particular steel is being used for lifting and excavation segment, where they use for the boom arm application. So previously, and many L&E manufacturers like JCB and X. So previously they used to use very 460 MPa grade. So when I upscaled it to a 700 MPa grade, there is a substantial weight reduction of 730 kgs per vehicle. When it translates to a CO2 emission because of the reduction in the weight savings, as well as this particular grade was previously being imported from the Europe, there are 3.7 tons of CO2 emission that can be saved. So, but that's beside the stories. We have our own challenges. When we, from our Kalinganagar plant where we have a casting sequence of 3000 ton. Now, if you try to design a new steel, unless and until you make the full campaign size, you generate a transition loss. Or you intuitively design a steel, a specification in such a way so that you can mix with other steels without generating a transition scrap. That leads to the challenge that you can make a very high strength low carbon microalloy steel with a very lean chemistry, and on top of it there is a requirement of attaining a very high impact toughness of 40 joule at minus 40 degrees Celsius. So the challenge was how to design a low carbon microalloy high strength steel, yet you get a very high impact toughness at minus 40 degrees centigrade. So we took up this particular challenge, and we thought of that anyway, high carbon microalloy steels, high strength steels suffer from a low impact toughness, but we resort to the crystallographic texture. So we will make a ferritic steel, we will orient the planes and the direction in such a way so that the fracture happens in a ductile manner. Those who are present over here has a very little understanding of the texture. It is the way you weave the crystals in such a way so that the favorable crystallographic direction of the planes are oriented. So we took up this particular challenge and sort of going for a microalloy strategy. And this is the bright field transmission electron microscopy image. So you can see very fine titanium, niobium, tau nitride, rock chip and circular precipitous present over here. This is the property distribution. You can see this is from a commercial product. Majority of the products are on above of 720 megapascal of the YS, in excess of 800 megapascal of UTS. Excellent, some 16% elongation, and look at these impact values. These are in excess of 80 joules at minus 40 degrees centigrade. So, and this is the fracture surface, which is a fissure, and it shows quite a lot of a ductile fracture. The way we did it, how we cracked it, is by engineering the crystallographic texture. So we made a very strong NT fiber, which has got a 55432 component over here, and a very strong RD fiber, which is 112-113 component, and readily reducing down the rotated cube, which is detrimental for a cleavage fracture. So this is the way we have nailed this particular product. And then we compared with the competitions. So you can see other manufacturers which are from the Europe and Indian steel mill, they go for different microalloy strategy. Certainly these are more expensive, and we literally gone for a very lean alloy design so that we can save in terms of ferroalloy optimization as well. So this is the crux. I'm getting the summary. So this particular steel which is being imported from the Europe now is being made in India, and we have completely made the import substitution. Beside this story, I would like to also share one pride moment with us. Tata Steel, along with Welspun in India, has made API X65H steel suitable for 100% gaseous hydrogen transportation for ERW line pipe. First time in India. And this is what we proudly announced. And we are looking forward to going for CCUS as well as ELSA for hydrogen transportation. Thank you very much. I think I'm within 5 minutes. I'm really
Thank you very much. It's a nice product that it is helping in our country's revenue to bring down the import.
Yeah.
Very good. Now I will request viewers, any queries please.
Are you also making X65 sour?
Yes. Yes, sir. We are making X65 sour for ERW up to 30 millimeter.
X90 also?
No. We are capped up to X80. Our commercial product is up to X60 non-sour, X65 sour, X80 we are on the trial phase, but we are X90 and 120 is still in the research phase. Yeah.
Because it would be useful for some of the projects we are doing for Tata Steel.
Okay. Yeah.
Your product, the impact, is 40 joules at minus 40 degrees.
Yeah.
So, what are in the European condition where the temperature drops down to maybe 60 to minus 60, minus 70? How does it apply?
So our transition is up to minus 60. So yeah. So we are in excess of 30 joule up to minus 60. Beyond that, certainly there is a DVT.
Any more questions? Only one question.
You're showing this impact value.
Yeah.
This is in longitudinal or transverse direction?
This is transverse.
Transverse.
This is transverse.
Okay.
But we did the anisotropy also because we understand because crystallographic texture is replaced by anisotropy as well. So there is a significant drop at 45 degrees.
Exactly, that's
Yeah.
because titanium addition generally reduces in certain angles. That's why I just wanted to know.
Exactly. So we experience anisotropy in this one, but these are all transverse values. These are all transverse values, and we are presently declaring it as an ISH 750 array also, as per ISH specification 5986, and where it doesn't specify for impact. So EN 700 MC, EN 10149-2 700 MC, as well as ISH 750 array, where EN specification calls for an impact. These are transverse values, definitely.
Then we come to the end of the presentation. Nice, excellent presentation, and it's an excellent effort in bringing down the import. That is very good. Excellent.
Thank you.
So coming up to the fifth paper, it is from IIT Bhilai. High entropy steels prepared by mechanical alloying and spark plasma setting. Mr. Yagnes, please.
Respected Anirban Das Gupta sir, Tapas Das Gupta sir, dignitaries on the dais, off the dais, very good afternoon. Today I am going to present my work on high entropy steel. It's relatively a new concept, and I had used mechanical alloying and spark plasma centering for consolidation and fabrication. So first we'll be discussing the critical issues related to high entropy alloys. Then we'll be talking on high entropy steel, Fe-based high entropy alloys, and mechanical properties. Then some concluding remarks. So if we'll see the sequence of material development, since time immemorial, the various human civilizations were known by the materials in importance. So we can see Bronze Age, Iron Age, and still iron and steel has its own relevance till now. People have thought of replacing this, but iron and steel is still not, it's irreplaceable. So many advanced material also were discovered, like quasi-crystal bulk metallic glasses, nano Benedict steels. And in 2004, the concept of high entropy alloys came. And mostly advanced characterization techniques like STEM, CS corrected transmission electron microscopy, and recently APT are being used for its characterization and understanding the structure microstructure correlation. So coming on to the concept, in conventional alloy we have one major element and 2 to 3 minor alloying element, and we have a single phase structure. However, for a long time it was considered if we have multiple elements, then we will have multiple intermetallic phases. However, in 2004, Brian Kenter from UK has stated that if we take elements in equiatomic proportion, then it will lead to the formation of single phase solid solution. And it happens due to the mechanism, that is severe lattice distortion, sluggish diffusion. And due to all these properties, this high entropy alloys and high entropy steels has a high thermal stability, which make them a perfect material for high temperature applications. Here we define, so basically we can have an equiatomic ratio or non-equiatomic ratio. Non-equiatomic means one element will be somewhat in excess and other will be adjusted, and the atomic fraction will be 5 to 35. And basically this kind of single phase alloys are stabilized due to the entropy effect, which is greater than 1.5 R. So why we are talking on this forum on high entropy alloys or high entropy steels? Because as yesterday discussed by many of the speakers, we need to recycle the scraps, end of the life products. For recycling the end of the life products, it is very difficult to segregate all this kind of product and remelt it. Sometimes we have some product which contain coppers. So copper and iron has a positive enthalpy of mixing and often led to the embrittlement in this kind of steel. So by using the concept of high entropy alloying, we can make high entropy steels, which will have a mostly solid solution phase, and will have some minor phase which will be strengthening this high entropy steel, and by this method we will be able to use the end of the life products and will be able to recycle and will be a small efforts towards the decarbonization. So the first article on high entropy alloys to high entropy steels came in 2014 from Professor Derek Rebbe Group, which is now Max Planck Institute of Sustainability in Germany, and they are actively working on these things. So there are comparison of the high entropy steel with the other kind of steels. So we can found that it has a good elongation as well as ultimate tensile strength, which make it a prospective material for structural application. So now let us see some examples in which we have designed and developed some high entropy steels. We can see we have varied the manganese and nickel, and the second case we have manganese chromium nickel, and third we have manganese titanium nickel. So we have taken different kind of composition, and we have seen how the microstructure and structure develop in this kind of alloy. So we can see the enthalpy of mixing is around 12.7, 13.83 and 13.83 for the last two cases. And if we'll see, as per the thermodynamic calculation, it is in the range for the solid solution formation. So when we saw the structural evolution during mechanical milling, it was observed that after 35 hours of mechanical milling, this Fe enriched high entropy steel composition led to the formation of a BCC phase along with the gamma brass type and B2 type second phases. And when this product was centered, the major BCC phase was retained along with the B2 type phase was also in minor proportion, and Fe5 Si3 type silicides along with gamma brass phase, as it was observed with the Rietveld analysis also. Now let us see the comparative phase evolution. So it was observed on changing the composition, the major phases changes from BCC to FCC, and at the last with titanium it is FCC plus B2 type high entropy steels. These are the mechanical properties, and we have observed that these are having very good yield strength as well as elongation. And these are few examples of the iron enriched high entropy alloys. So you can see we have a 12-phase structure over here, and we have a BCC and FCC phase after the spark plasma centering, and with a very good mechanical property and low density. So it comes under the regime of low density high entropy alloys, and the compressive strength is also very encouraging in our case. So these are the summary, which optimization of the composition, we can get BCC plus FCC along with the B2 kind of microstructure in this kind of alloy with very good mechanical properties. These are the concluding remarks. So I will conclude. This is a new renaissance in the physical metallurgy, and this can be used as a alternative towards decarbonization and utilizing the end of the life products. So I would like to, these are my mentors and colleagues whom I would like to acknowledge. My supervisor, Professor N.K. Mukhopadhyay, and other senior mentors from IIT BHU, Bhaskar Majumdar from DIIT Pune, Professor K.G. Prashant from Tactic Estonia, Dr. Vikas Shrivastava from NML Jamshedpur, Dr. A.K. Chaube from IMT Bhubaneswar, and Dibyendu Chakravarti from ARCI Hyderabad. And I would like to acknowledge other colleagues also, Dr. Vikas Shiva, who is now at Seoul National University, and other fellow colleagues. So these are few of the references which I have used for this presentation. Thank you, and I will suggest you to visit Varanasi, where the first metallurgy department started in India, and now the city has been renovated like anything. So thank you all.
Thank you very much. nice in-depth study of this subject. Now I invite queries from the viewers, please. Any query? Okay then. Okay then. Thank you very much. We are coming up to the last session, last paper of this session. That is from NSPC. NTPC initiatives in decarbonization through CCS. Presented by Ankit Gupta.
Good afternoon all. So for today the topic would be NTPC initiatives in decarbonization using carbon capture and utilization. Start with a video.
Modern life depends on electricity. A bulk of electricity is generated by using fossil fuels. And the use of fossil fuels releases carbon dioxide. To alleviate this, carbon capture, utilization and storage, that is CCUS, can play a critical role. In CCUS, carbon dioxide is separated from gaseous emissions through custom-designed physical, chemical and biological processes. Upon capture, carbon dioxide can be synthesized to produce an array of green fuels, fertilizers, chemicals and other green products. NTPC, the largest power utility of India, is setting up a carbon dioxide to green methanol plant, where carbon dioxide is stripped from waste flue gas and catalytically hydrogenated using green hydrogen to produce green methanol. This carbon dioxide to green methanol plant comprises 3 blocks: carbon capture block, hydrogen generation block, and methanol synthesis block. Carbon capture block. Carbon dioxide of flue gas is captured in the absorber section using modified tertiary amine. Carbon dioxide rich amine is sent to the stripper section. Here, high purity carbon dioxide is stripped from amine using a thermal process. This plant is already commissioned at NTPC Vindhyachal Power Station and is running successfully. Hydrogen block. Green hydrogen is produced in a proton exchange membrane, that is PEM electrolyzer. PEM electrolyzer has been specifically chosen because of its high turn-down ratio and ramp rate, and can be easily coupled with renewable power. Methanol synthesis block. Here, carbon dioxide and hydrogen are catalytically hydrogenated at high pressure and high temperature to produce fuel-grade methanol. Fuel-grade methanol is sent to a set of distillation columns where water is separate and very high purity methanol is produced. The success of this carbon capture and utilization project of NTPC will lead to the reduction in greenhouse gases, while utilizing its natural resource and protecting investments already made in the power and mining sector, thus realizing India's COP26 commitments and reaching the net zero goal by 2070.
Thank you. So let's start with the presentation now. Actually, real picturization is we wanted to have a feel of the power plant which is being set up right now. This video was prepared last year for G20 as well as COP26 and presented there. So we conceived this project in 2020 after the directorate from DPIO to have methanol economy. So we have electrical based economy, strong economic growth and extensive electrification going on in rapid urbanization. Electrical mobility, trains, two-wheelers, three-wheelers, four-wheelers going on. Electrical dwelling, mobile applications, cooking, etc. CO2 emissions are majorly taken care in coal-based power plants.
significantly of 62% was noted in 2020, and we are expecting it to be 54% by 2030. In order to sustain coal-based power plants, it's important to reduce the carbon dioxide intensity needed to be reduced. Here we have the graph for 2020 and 2030 expectations. The source is Niti Aayog, and way forward to take the carbon capture utilization in these sectors. There's a next we have this graph for the by McKinsey. It shows the global carbon dioxide emissions in all the sectors: power, iron, steel, cement, and chemical and refineries, hydrogen production as well. So retrofitted the CO2 capture in all these infrastructures as per the topic today. Tata Steel Jamshedpur pilot scale carbon capture plant for 5 tons per day was already commissioned from Bhilai. They are using carbon dioxide capture from blast furnace gases. IOCL also has done the R&D work for amines and biological enzymes based carbon capture plant. Coming to our technology center, Netra, we are R&D experts, and in the field of this carbon capture, we have done physical processes, chemical processes, and biological processes. Each pilot plant, and we observed that 85% of carbon capture absorption can be based in the chemical route through modified amines. Next, we are ongoing projects are CO2 to methanol, CO2 to ethanol at Lara, and CO2 to methanol at Vindhyachal. CO2 to urea will be coming up at Lihan. CO2 to sustainable aviation fuel will be coming is already planned. This will not only ensure the energy security, food security, aviation also. Also, in the sector of the urea, when we are going ahead, we will also ban our imports or reduce our imports. Coming back to methanol, methanol can be blended with petrol with 15% M15, and there will be no change required in IC engines. Methanol can be substituted 100% also with a small tweaking engines in IC engines. Diesel, methanol can be converted into dimethyl ether, and then further it can be used as a replacement of diesel as well. We will be using methanol as a substitute of LDO. Methanol has high octane number, and it is a base chemical for all the chemical industry, formaldehyde, formic acid, olefins. The market size of methanol is around 2 million tons per year. Domestic production 0.2 million tons per year, import 1.8 million tons per year. Potential use of methanol in shipping industry is now going in a large scale. These are the building blocks for the methanol. Carbon capture 20 tons per day was commissioned in 2022. Hydrogen block 2 tons per day, uses 5.5 megawatt of electricity, is already commissioned at NTPC Vindhyachal, and it is working at 95%. Methanol synthesis plant is done by catalytical hydrogenation, and plant is under erection stage. Almost 98% plant is erected, and commissioning has started with hydro test. After this, methanol distillation, and then methanol grade A is produced. Grade A methanol has the purity of 99.85%. Grade AA methanol has the purity of 99.85%, but with few traces of ethanol. And then there is grade methanol, which can be used for HPLC for is 99.9%. Methanol for ACS requires is 99.8% pure, and methanol for anhydride is 99.8. So methanol, coming to the basic properties of the methanol. Methanol molecular weight is 32, specific heat is 2.43. Calorific value is gross calorific value is 22.9, net calorific value 20.1. So by this, methanol ships are also going on right now and replacing it of diesel. This is the plant captured plant which is commissioned at Vindhyachal. Right side 20 TPD carbon dioxide capture plant. Left side the photograph of the ongoing erection of methanol plant and the PEM plant which is commissioned. These are basically the amines which are used for the carbon capture.
Please make it fast.
Yes. These are the amines which can be used for carbon capture and few catalysts available in the market. The most important comes in the financials. Only 1% cost is for the methanol carbon capture, 20% cost is for the methanol production, and 79% cost goes for the hydrogen. And while we see in the terms of capex and opex, capex is around 43%, whereas opex is 57%. Next is ethanol, that I will not go into depth, just a block diagram over here and showing the capex and opex. The capex is again 25% and opex is 75%. That is due to the cost of electricity. Thank you.
Thank you. Thank you, Mr. Anshul. May I invite only one question from the viewer side, please. Only one question.
Yeah. I have a question. What is the approximate plenary cost, capex, for this 10 TPD plant? Just ballpark figure.
So I have deleted here, we can see the space. I have deleted that part. Okay, but we can just tell verbally. The cost of this plant was 150 CR. Cost for 1 kg of methanol comes around to be 45 rupees.
45 rupees.
Yeah, that is with considering 2.5 rupees per kilowatt of electricity.
Thank you.
Per unit electricity.
Thank you.
Thank you. Thank you,
Just
Mr.
another
Anshul.
small question, sir. Just one more question. We are now into blending ethanol with petrol. Can we blend ethanol also with petrol?
Can you repeat, please?
We are into, India is now blending, in fact Brazil is the leader for this.
Yeah.
Ethanol blending is being done for petrol.
Yes.
Can methanol also be blended that way?
Yes,
Are
methanol
we
can be
doing it
blended.
here?
Yes, methanol can be blended. M15 is the grade where 15% of methanol is blended with petrol, and M100 pure methanol can be substituted with our gasoline.
No, is it being practiced presently in India?
Yeah, they are doing in shipping industries. Shipping, big ships are working on this. In UK, they have projected the scale for consumption also. In US, they have made the territory that they can only ships based on green methanol should enter. Here, still we are making it green. That is not we have done it as of now. Green means the source of electricity will be green, renewable energy. Nothing else it makes. Otherwise, it's a gray.
Thank you.
Thank you. Thank you. We come up to the end of this session. Now I request our session chairman, Sri G.S. Prasad, XC or SP SAIL, for his expert comments. Sir.
Thank you, Sarkar. Good afternoon, Sri Anirvan Das Gupta, Director in charge, Bhilai Steel Plant, Sri Anjani Kumar, ED Works, and other dignitaries of the dais, my colleagues on the dais, and all the participants. It's my pleasure to be here, coming back to this particular hall and chairing this session. I'm thankful to the management of Bhilai Steel Plant for organizing such a beautiful seminar on a very relevant topic and inviting me to this seminar and giving me an opportunity to share my little bit thoughts, whatever I have collected, and then I'll comment on the papers. Maybe slightly time is running out, I know, but so, as all of us know, that India is the second largest producer of steel today, only after China. It has an operating capacity installed of 161 million ton, and in FY23 produced around 140 tons. And Indian steel industry is poised to grow at a very fast pace and reach 500 million ton by 2047 as per the National Steel Policy. We know that steel industry is a very heavily dependent on the energy consumption, and the CO2 emissions from steel industry is quite high, and it is very hard to abate. We also know that the per capita steel consumption is only 81 kg as of now 60 kg by 2030-31 and 220 kg by 2047. So it's since India is growing at a very faster rate and infrastructural growth requires a lot of things to be done, steel finds a place as backbone of all the infrastructural growth. So naturally steel industry will require a lot of capex and opex, but at the same time the requirement of decarbonization is coming on our way because the climate change is very fast happening and global warming is a real problem for us. In the COP26, that is the Conference of Parties, 26th conference of the United Nations Framework Convention of Climate Change, Government of India is committed to become net zero carbon emission by 2070. Accordingly, Ministry of Steel has set up target to reduce carbon dioxide emission by 20% by the year 30-31 and midway to 50% by the year 2047 and net zero by 2070. So this gives a lot of responsibility to all the steel makers, and in India around 40 to 45% is through blast furnace. If I am correct, I may be wrong also. BF route and rest through scrap steel scrap, that is secondary steel generation. I may be wrong, I may be corrected also. So anyway, so these type of seminars and a forum between interaction between the academia and industry requires very much, and Government of India has to go for actually we have to go for modifying our education system as well as industry to have more interaction, which is very much there in Europe and other parts of the world, developed world. India, it is somewhat lacking, but I am very happy that in this seminar I find lot of papers from the academic institutes who have done lot of work on the developing new steel or developing new ways of finding the best uses and working towards the cause of decarbonization. So industry experts have to take advantage of this expertise or the research work from the institutes. So I am very happy that this particular seminar has made a beginning of the interaction between the academics and the industry in Bhilai area at least, with IIT Bhilai giving a very thorough technical paper and NIT Raipur also giving a lot of insights to what can be done. So with this, I will come to the papers. The first paper presented by Sri Vishkarma of Apollo, it really based on the coated products. The basics was to reduce the corrosion losses and use of galvanum and other coating material to make structures long life, giving long life, at least what I could gather it is 5 to 6 times. So that is a take for the maintenance engineers, because I know as a maintenance engineer to maintain the rooftop and the purlins was really a problem in the mill area or any of the industry, if you say, because steel industry has a corrosion, highly corrosive industry. So the vapors are very corrosive and corrodes the purlin and the top structure, roof structure, and there had been cases of roof collapses and structural collapses. So this is a very good take, and one should take up these things, study this particular paper and try to take advantage of this available literature. So thank you. Mr. Vishkarma, in very lucid way you have explained the technical, not very technical, but the real use what industry experts can take up. And you have told that you have started with HL Bangalore. Yes? Right. So the second paper was for decarbonizing SAIL. That was by Mr. Sandeep Sahu. So he very lucidly gave problems of SAIL, whatever it is there, and what are our targets, and what efforts are being given. That beautifully he has given the SWOT analysis. So and by 2030 we are planning to do through MODEX and best available technologies. And by 50 you have to go for obtaining carbon neutral task, and SAIL will, by 70 you are going for carbon capturing and renewable energies and green energies. So that is very lucidly he has explained the total gamut of the things. So thank you very much. It was a good effort by and the SAIL is planning to about 1 lakh crore capex for these purposes. That is a very good thing to note. Another important thing, that use of pellets to 25 to 30%. Now it has been very close to my heart because I have seen the blast furnaces performing very well and giving that 8,000 volume blast furnace will definitely give around 10,000 tons of production per day, provided you use more than 15 to 20% of pellet. Now he has gone up to 30%, so that is a good effort. If SAIL can plan it, it is very good. Then other things like oxygen enrichment and PCI to CDA, PCI to oxygen, hydrogen injection is another area. That green hydrogen, when the hydrogen becomes of the compatible price, then we can use it in the steel plants to give a better productivity plus cleaner steel. Now today we know that we have our earth to make sustainable. We have to go for a greener steel, or else people will not take your steel. So one way or other we have to go. So all steel makers have to go for this type of efforts. So thank you for making it very light, and the targets which you have put, that is 2.19 ton by 2030 and net zero by 2070, I am sure it will be achieved. Then the third paper was on the residual stress of rail. So he has very nicely explained the straightening process, which is successive bending and unbending, because I am also a man from plate mill, so I know the levelers quite well. So rail mill also is like that, but it definitely produces stress. So he has very lucidly given the technical part, how to control the residual stress, and which is very important because rail touches the life of everybody, and any higher stress or anything will result into rail failure, which not only breaks the rail or we have to maintain the rail, but it really gives a problem in terms of material loss, manpower loss and life loss, because that is very important. So it is an important aspect, and once the rail failures will be less, it will indirectly contribute to the cause of decarbonization. Now Mr. Subhankar Das Bakshi from Tata Steel, very shortly he has explained very nicely the uses of history of development of high strength steel that is around beyond 700 MPa and with good impact property. So it's definitely very good effort by Tata Steel to develop this, and indirectly, when the weight of the earth-moving equipment will come less, giving the same strength. So definitely it will indirectly contribute to the cause of decarbonization. So thank you very much, very short but very sweet. Now coming to the most technical paper from IIT Bhilai, Mr. Yagnesh Sarangi. High entropy alloys, I think it was a new subject for all of us, at least for me. It was a new subject, and I asked few colleagues, do you know high entropy steel, no? High entropy steel, but good that it's what we could get is that it is applicable for the high temperature zone. So definitely a steel plant which deals with high temperature can look forward to this development and make for commercial uses. So since IIT Bhilai is here, you can always interact with Bhilai Steel Plant, which can give benefit to the whole of the steel plants. Thank you very much. Now coming to the last presentation, that is NTPC by Ankit Gupta. So he started with a presentation which was so lucid and good. So carbon capturing and utilization and storage. I think storage is also there, Mr. Gupta.
So we are working on the carbon capture storage part also. That is a different project conceived with IIT Bombay, and we have marked the areas in the entire country where the sequestration can be taken up. But that will also happen on carbon capture only from the flue gas. So that I didn't explain.
So it was a good effort, and coming to development of the methanol and that can be used in the aviation fuel and in diesel, as a replacement of diesel.
Methanol can be converted to diamine in the next stage. It can be substituted for diesel.
So that was a very good insight to the development happening for carbon capturing and converting it into usable aviation fuel or the diesel, which can definitely result into decarbonization effort for Government of India as a whole. So thank you for nicely explaining it. And he has also explained the capex and opex for the industry expert to take decisions. So very nicely done. Thank you. And as already I have told that COP26 net zero emission is possible. You have to start a journey. You cannot go on sitting at a place seeing that the mountain is very high. But once you start climbing, you will definitely reach the destination. Target is 2070. You can reach by 2065 or maybe 2075. Doesn't matter, but you have to start your journey. And I am very happy that Iron and Steel Review and the management of Bhilai Steel Plant and the Institute of Metal has taken this on a serious note and organized this type of seminar on decarbonization. More such seminars required to happen to give impetus to this cause, and definitely it has the support of Government of India, because we are committed on COP26 to get to net zero. Another very important thing which was touched by that use of slag as a soil reconditioning. It really requires, because I have also worked when I was in Rourkela, that Odisha Agriculture University and Technology. They have worked on it and had a good result, but this needs to be taken forward. So thank you, gentlemen. At the end, I thank the management of Bhilai Steel Plant and the organizers, Mr. Tapasya Dasgupta and his team for inviting me to this seminar and chairing this session. I am very much thankful to you, and that's all. Jai Hind.
Thank you so much to our session chairman, Mr. G.S. Prasad sir, for sharing his valuable insight and summing up all the 6 presentations. So thank you, sir. And I also express my sincere gratitude to our reporter, Mr. Sarkar, sir. So thank you, sir. And now we move ahead. And I request our session chairman, Mr. G.S. Prashad, sir, kindly come on the stage to felicitate our presenter with a memento. So I invite and I also request Sarkar sir to assist him. Firstly, Mr. Ashok Kumar Vishwakarma from VP APL Apollo Building Products Private Limited. And I request audience to please give him a hand for the presentation. Now Mr. Sandeep Sahu sir from Bhilai Steel Plant. And I also request again the next is Mr. Ravi Pratap Singh sir from RDCS Bhilai. Dr. Shubhankar Das Bakshi sir from Tata Steel. Mr. Yagnesh Shadanki from IIT Bhilai. Mr. Ankit Gupta, scientist, NTPC Netra. Now I request our CGM in charge services and director NSPCM, Mr. P.K. Sarkar sir to kindly felicitate our session chairman with a memento. And I request everyone to please give him a huge round of applause for session. Now I request Mr. Indrajit Singh Gupta sir, CGM Contract Sale Works, to come on the dais and felicitate our reporter, Mr. P.K. Sarkar sir, with a memento. Please sir, come on the dais. And I request everyone for the kindly give him a huge round of applause. And now I request everyone to please join and for a group photograph, sir. So come on the dais. And all the presenter with our session chairman and reporter. Sir, photo. Thank you, sir. Now you can join the sessions. Yeah. Please join your respective sections. Thank you. Thank you once again. Now we move forward to the session. Before the valediction session, we have our distinguished guest, Dr. M.K. Verma sir, who is the Vice Chancellor of CSVQ, and he is known for his administrative reforms at CSVQ. Sir carries more than 3 decades of experience in the field of academics. He has done several research papers at doctorate level. He has also written and published more than 240 research papers in his publications, and also authored about 10 books. So, sir is also getting the awards such as Young Scientist Award, Gold Medal for the Best Research Paper. So, I request, sir, please come on the dais, and I request you to, sir, kindly give a brief about the 2-day sessions. And due to some reasons, sir was not present yesterday. So, we welcome you, sir. And I request our steel gathering to please welcome him with a huge round of applause.
to be amongst the people who are making, and who will make the nation in continuous process. By production of steel, that is, we can say the bone play in a body, that role we are playing. So I am very happy to be amongst this great gentry who has been always contributing to the development of nation. Also, I am lucky to have attending this last session of this seminar, where many new things had been propagated, and it was giving us glimpses of future, how we have to develop and what are the other achievement as well as targets for our steel industry. Of course, that is quite obvious. 2070 is the target. But meanwhile, how to achieve this target? We are coming back to the technology. What is the status of the present, and what will be the required research, R&D and development for all the processes. And whenever development is concerned, technology development is concerned, its application is concerned, nowadays it is very popular and very emerging area, that is artificial intelligence, which is based on deep learning, machine learning, and capable to deal with large number of data, with analyzing it more accurately, as well as taking some decisions based on that. So what I feel that AI will, in the coming time, in the coming future, is going to become a great instrument for dealing with all this data, particularly whenever we talk about the steel. We can say that carbon footprint measurements, whenever carbon footprint measurements, that is our target, its measurement as well as its prediction. If these two things are done with the steel industry, then definitely we are going to get a dynamic system where we can go for controlling it in much more effective way. Then minimizing the waste production process. Waste, we all are aware how significant it is and how the energy and all the energy, while we are looking upon the percentage of waste, we find that a lot of carbon has been emitted even for this waste. So this particular waste production processes, if we are going to optimize and we are taking the help of AI, again we can go for a reduction of 4 to 10%. That is one of the study. Of course, this is a predictive study. Similarly, whenever all the processes of steel manufacturing is there, energy is the basis, and whenever the energy is coming, nowadays it's certain industry, AI is doing wonderful job for optimizing the use of energy as well as redistributing it. So again, 5 to 10% efficient, we can make the same system after application of AI. And lastly, about which also here discussions was there, that carbon capture and storage, CCS. One of the study which is done by International Energy Agency, it shows that cost of CCS can also be reduced by up to the 30%. So this is the potential of new technology based on this AI and your deep machine learning. So these new technologies are to be implemented, and that is the, I think, the responsibilities of academic institutions. And this is still in its developing stage itself. So a proper collaboration, as Mr. Prasad was indicating about, and that is the need in our country, that industry and institute collaboration. So that is the zone where we can focus now. So I should not say much more about the subjects because I feel that much more expert with the experience are sitting before me, and that is the application of technology, and that is the production as well as development of country in the direct way. So lastly, I would like to thank DIR, Bhilai Steel Plant, Das Gupta sir, and all dignitaries and officials of Bhilai Steel Plant and other organizations. Thank you very much. I wish that this particular seminar will be yielding some collaboration and application zone of academics with the industry. That will be a present condition for we academicians, as well as it will be a collaborative for the industry. Thank you very much. Wish you all the best.
Thank you so much, sir. We truly appreciate the time you have took to share your knowledge with us. So thank you so much, sir. And there is an important announcement. The after lunch session that the suppliers need is organized at Bhilai Niwas. So all are requested to kindly proceed after the lunch at Bhilai Niwas. The session will start at 2:15 p.m. and all CGMs and all delegates are requested to join us at Bhilai Niwas for the suppliers meet. We move forward now. I request Mr. Anjani Kumar sir, who is a graduate in mechanical engineering from PIT Centre. He has been serving SAIL past 34 years, and he was also instrumental in changing of blast furnace 2 at Bokaro Steel Plant and commissioning of the new blast furnace Kalyani at ISCO Steel Plant Banpur. Under his leadership at Bhilai, BSP has shown remarkable growth in production of hot metal, crude steel and cylinder steel. We welcome sir, who is currently holding the post of Executive Director Works at Bhilai Steel Plant. I request for sir for the welcome.
Thank you. Very good afternoon to all. Respected DI sir, Boma sir, and all the dignitaries who are sitting in front. The decarbonization of the steel sector and the advancement of the infrastructure development is a matter of concern to me as a head of the works SAIL-Bhilai. In this conference, participants from the different companies like MS, APL, Apollo Building Private Limited, Abitec, JSW, Prime Metal, Denelli, SMS, Tata Steel, TRL, Sarvesh, and many more our sister concerns, and above all the renowned institutions like NIT and IIT Bhilai gathered, discussed and highlighted the most pressing issue, that is decarbonization. The steel industry is a cornerstone of the modern infrastructure and is a major player in this narrative. The steel sector is responsible for about 7 to 9% of the global carbon emission, making it's a critical area for decarbonization. Being a just example, I would like to show you. Being a head of the Bhilai Steel, what is our conditions? Our energy per ton crude steel is something like is 6.6 gigacalorie. The carbon emission is roughly about coming, it is a 2.55. Sometimes it goes in the rainy season, it goes 2.75 per ton crude steel. Obviously, it is due to very high gain in our input and very high, that result in a high slag ratio. So, this topic, why important for Bhilai is that these are the reasons. We are using so much high energy for making cotton steel. Then coming to the India, A data released by the United Nations Economic and Social Commission for Asia Pacific, that is SCAP, you see it in a short form. According to them, the loss for the climate change due to high emission could be 35% of GDP for India. It will be 35% of GDP of this India compared to the 24% of GDP in other Asian countries by 2100. So that's why the topic is very important for us. Through this session conducted in this conference, we have learned about the latest advancement in green steel production, carbon capture, renewable energy integration. During our discussion, we delved into the complexity of the steel industry, from the traditional blast furnace method to innovative alternative. For any problem, there are different approaches. One approach for less emission is what will be? You use less. You use less amount of steel for your usage. How this possible? Obviously, again, the expert or domain area of this field, better steel. So, lighter and a stronger steel structure, replacing the reinforcement concrete, enhancing production, and at the same time reducing the emission by 60% by producing flat product EHRC. A state of the art rail which produced by the Bhilai, so that if you will produce, we will produce better rail, running our train, our goods train, all will run faster way, and finally emission will be less. So this is on our responsibility, and that's why one of my SMS to colleague Mr. Sao told that we are going to produce better and better 350 grade steel. We are making our most of the steel, if you will see, almost roughly 70 to 75% to the route of BF-BOF. And this route is highly energy consuming. If you will see in India, from last 4 or 5 years, lot of private player came and lot of new blast furnaces introduced in India. So, coming 25 years, we cannot avoid this route, BF-BOF route. So what is the alternate? The innovation in injection method, hydrogen direct reduced pellets, and an open slag bar furnace. That is another approach. The role of technology, and Mr. Verma sir had told us the AI, machine learning, all these things we have to incorporate here. Another idea which I have read many times, steel is a sense energy consuming. Why we are not thinking about the modular nuclear reactor? The Indian government is very serious, and I think they are already talking with the L&D that modular nuclear reactor, their capacity will be start from 220 ton up to 550 ton. 550 megawatt, 220 megawatt, 550 megawatt. So that is also a very good idea to put a smaller nuclear plant and take the energy, nuclear energy, and save our society. SAIL is very serious regarding the emission. and it is taking many steps towards the decarbonization, but we can develop and implement low carbon production method, invest in research and development for the new sustainable technology, and collaborate with the industry partner to share the best practices to drive the change. We must apply our knowledge, skill and creativity to transition our world to a low carbon future. As we go our separate way, remember that the decarbonization is not just a goal, it's a journey. A journey, let us carry with us the lesson we learned here, the commitment which starts from this conference. So, by doing step by step, we can improve our society, our planet, and we will leave better world for our next generation. Individual commitment to a group effort, that's what make a team work, and a company work, and a society work, and a civilization work. So let's together lead the transformation towards a decarbonization steel industry and creating a better future for our planet and future generation. Thank you. Thank you everybody.
Thank you so much, sir, once again for your effort and dedication to sharing your expertise with us. So thank you, sir. Now, I request our DIC sir, Mr. Animal Das Gupta sir, to kindly felicitate our guest speaker for the today's session, Dr. M.K. Verma, who is the Vice Chancellor of CSBTU. So I request sir, please come this side. Thank you, sir. Now, I also welcome Mr. Anjali Kumar, sir, Executive Director, Works, Bhilai Steel Plant, and who is also the Chairman of IAM Bhilai Chapter. And I request sir to felicitate him with this. Thank you, sir. And now we are at the end of the today's sessions. So I request Sri S. Majumdar sir, who is the convener of Indian Steel Conference, to come on the dais for the concluding remarks for this technical sessions.
Well, it was not only a technical session, it's perhaps a reunion for all those people who have been associated with this industry for such a long time. We have seen veterans, more than 70 years old, 75 years old, who have also come to chair the session and share their remarks, their opinion about what the steel industry is all about. We have seen the youngsters from NIT, we have seen from IIT who have come and presented. A lot of faculty members, well known to me when they were students, they also came and presented. And above all, we had such senior people from the industry joining here to share their views about what the steel industry is all about. A special thanks perhaps is deserving for this Bhilai Steel Plant of Steel Authority of India, who really decided to have a link with Santosh Mahatma of ISR to have a program down here in Bhilai. As you all know, Bhilai is not really well connected by the aircraft, not perhaps by the rail, but it's an ideal location. We thought of doing it in some other place, but due to our DIG excellent opinion that we have to have it here, and I think a big round of applause for the team which made it all happen. lastly, I just wanted to tell you something. Now that we have now come across a lot of educational institutes who have participated out here, I have suggested to the organizers of this event to have it linked now to the industry, whether we can have the industry academy being done perhaps here, perhaps in Bhilai or Raipur or even Rourkela, so that we can take this forward. As you know very well, we are losing out the students of metallurgy who are not really joining the industry as such. They're going over to the IT sector and others, you are all clear about it. So now to really emphasize that we get good students joining the industry, especially steel or even non-ferrous metals, I personally want them to be closely associated for this event, perhaps in the next future. We'll be discussing about such events for the next 1.5 years, and we'll promise that we'll definitely come back to Raipur, definitely to Bhilai, to make it all happen. And finally, to really appreciate the efforts made by the organizing team out here, headed by Mr. Anirban Dasgupta, supported by Shankar, supported by others, etc. Let's have a standing ovation given to all of them, please, before we have a standing ovation for all those who have really brought our hearts to make this happen. It's a great thing for us, especially for all those